What's up guys, it's Cole with Tulsa Welding School. Today, if you don't mind, I'd like to show you how to set up for high frequency TIG. I'd like to show you a couple practical uses for it, and then I'd like to show you a couple tips on how to get your beads running straight. So what makes this part different from normal TIG, what makes high frequency set apart from normal TIG is this remote setup. Not just this remote setup is going to allow us to have what's called a high frequency startup. More or less, we're not going to strike the tungsten anymore. We're not going to lift it or attach it or anything anymore. We're going to hover it really close, step down on the pedal, and then that will create our arc. Whenever we want to get done, we will let go of the pedal and that will kill our arc. The benefits to that are huge. We will always have gas on our TIG welds, which gives it perfect terminations. If we were to do lift arc, you have a tendency to snap the arc off of there and pick your tungsten up off of the, pick your gas coverage up off of the weld while it's still cooling. And even if you were to go back and hit it with post flow, that real brief moment where it didn't have any gas coverage really kind of damages it. So high frequency lets you have a touchless, don't have to move it, start and stop. It's done with this pedal right here. So how do we set this up? First off, I'll show you, it's got a slot in this receiver right here at 12 o'clock. Then it's got the opposite sort of a keyway setup on the machine side of this deal. So we need to get that slot lined up with that keyway, and then we're gonna start screwing that in. And as we screw it in, a lot of times you can see it starting to get power. See it? A lot of times I'll get it kind of in there and it'll feel like it's tight and like it's screwed in all the way. It's not yet though. There's a lot of pins in there and there's a lot of things touching, and so we kind of need to wiggle it around a little bit, and that'll free them up, and then we can keep screwing it in. So I like to just kind of keep wiggling it, keep screwing it in. All right, so we got it fully seated. We got it all the way down in there. That's important to make all the pins touch inside there so everything works, okay? This one is wireless. It's really nice. Sometimes they're not wireless. Sometimes they have a cord going to it. So you're usually gonna have to sync this pedal up. Luckily, mine right now is already synced. You can see it's blinking really fast right here. If it wasn't already synced up with this Miller setup, guys, there's a button right behind this Miller symbol. You kind of can't see it. I'm gonna push that button, and you can see the beat change, right? The blinking is slow. So now I'm gonna press down on this pedal more and more and more, just keep kind of pressing on it, and that's gonna cause it to sync up. And you can now see that it's blinking fast again. That means it's synced. And then so you could see now me pressing down on the pedal and it trying to weld. Now that we've seen how to sync the pedal up and how to get it on high frequency, we can move on to the next setting, which is going to be either the remote standard or the remote hold. So standard is going to make this thing work like a gas pedal, where more or less the more that I press down on it, the hotter it's going to make my bead. Hold is going to make it to where whatever amperage I set it at, I step on there and it will ramp up to that amperage, and then I don't need to worry about keeping it steady. I can kind of ignore the pedal, and when I'm ready to turn it off, I'll step on there again and it will ramp down and turn my arc off. So I'll give you a real quick example. You can see right now it's on standard, so I'm going to press down on the pedal and you can hear it starting up, and I'm at 17 amps, 30 amps, 80 amps, 112 amps. Down, up, down, up, down, up, and then it'll turn it off, right? So then hold, I would step on it, it'll ramp up to 112, and then I step on it again and it turns off. Those are the two settings over there. For today, guys, I had it on remote standard. I was just kind of feeling the pedal out myself. I like it like that because I don't always want the exact same heat. I like to kind of feel what I'm doing as I'm going. Okay, before we go on to the next step, I'd like to stop and kind of explain the amperage for what I'm gonna do. It's gonna apply to the bigger the wire, the thicker the metal, obviously the more amps I'm gonna have. What I'm looking for though, guys, is I will press down on that pedal until I see the weld start to flatten out on the edges. If it's rounded, if my beads are rounded on the sides, then that's not enough heat. Okay, so I would then set for the smaller wire that I'm gonna run for you guys today, I would probably put it around maybe 70 amps. which is way higher than I'll ever need, but I like to have some backup reserve power. If I was going to run a thicker wire, maybe like this 332nd wire, I could get it up to maybe 100 amps. And then I would adjust it with my foot. I would adjust it with my foot according to, here is the round metal, and the more that I press down on that pedal, the more that it spreads out. And I want the edges of it to just flatten out. If it was to go any wider than that, then now I've got it too hot and I need to back everything down. The next row of settings on here, though, after that, we've got our pulsar, our sequencer, we've got our gas and our dig, and we've got our AC wavelength. That's not going to get covered today, guys. I'll explain to you what pulse is real quick. It's really, really useful. More or less, if I could find the exact right amperage, if I knew exactly what to set my machine at, I could put the pulse on, and instead of controlling that heat constantly with my foot, it would go pow. Perfect heat, pow, and then it'll shut off, and it'll pulse on and off like that. Power, off, power, you'll feed the wire in, off, power, feed the wire in, off. It's really, really useful because that real quick turning off right there keeps the heat down on your metal, and it makes every single dot be the exact same. You don't have to worry about, as you're welding, things are getting hotter and you may be having to mess with that pedal, maybe back off the pedal to lower the amperage while you're welding. Okay, everyone, one of the main problems I see when people TIG weld is that we're not understanding one of the fundamental concepts of welding. You have to also melt the base metal, okay? Kind of one of the things about physics is you can't really take a liquid and a solid and get them to bond like that. Let me give you an example. If I needed you to take these 2 ice cubes, I'm going to give you 2 ice cubes. How would you then bond those 2 ice cubes? You'd have to melt them, you'd put them maybe in a glass, melt them, and refreeze them, right? And whenever they refroze, they became a liquid, then you put them in the freezer and they cooled down, got cold enough to become a solid, and then they bonded, right? Okay, well, what if I was to take a glass of water and drop, which is a liquid, and drop a solid ice cube into it? Would it instantly just bond with that water? No. It would have to take a little while. It would have to melt into that water, and then we could refreeze the whole thing, and it would then all be one solid piece, right? That works just the same in steel. Water and steel work exactly the same. They're just really kind of different temperatures, okay? So, whenever I'm welding, if I don't have a very sharp tungsten, if I'm not aiming it down into the base metal, if I'm maybe too far away and it spreads my arc out too far and maybe tries to heat up too big of an area, I'm not able to get the base metal wet. So real quick, if I may, I'd like to give a couple tips that I think are really useful on how just to make these beads successfully work. I'm going to talk real quick about how I like to hold my torch and feed my wire. Depending on what I'm doing, remember we need to always try to keep that tungsten aimed into the base metal. So if I was going to do like I did earlier with those high frequency welds, I would want to, I take and hold the torch like this. I make a finger gun, bang, bang, and then I set the torch like that on top of it, and I kind of hold the button. Then I'm able to set on my palm right there, and I'm able to kind of use it like a pin. And I feel like that's how I'm drawing and how I weld. I can just go just like that if I wanted to weld flat. This hand, if I don't want to have it up here in the way, I don't want to be trying to reach through that, so I like to keep it really low, off to the side, maybe something like this, and then either feed that wire in, or if I'm trying to run a smaller bead, I'll just kind of do a tap. So for our high frequency weld that I'm going to show you, if you can imagine that your wet spot is right here, we've got to get this wire into that wet spot without our arc melting it first. If I was to have my tungsten really high, my arc would then be spread out, and before I could get my wire into there, it would melt it maybe out here. If I was to have my tungsten aimed forward really aggressively, my wet spot would be right there, and it would melt that wire before I could get it in there. That's the main point I've been trying to make, is we've got to keep the base metal wet, and we've got to get this wire right there where the wet spot is. So to do the high frequency weld here at Tulsa, I would hold the tungsten really close to it, right over that wet spot, and I would just tap this wire just like that. So if I was going to run flat, tiny little beads, that would work great. I could set my hand down and go like this. If I needed to change the position maybe to horizontal, I could then again do the same thing. I could do a free hand like that. Some people like to take and hold the torch like this and then put their fingers out and hold that. Maybe there's a piece of metal right here and they will weld like that. That's really common. You would put something maybe on there called a TIG finger so that you don't burn your fingers so bad, and you would just hold your tungsten really close. So that's a way to freehand. The last way that people like to move the torch, or that I like to move my torch, is by walking it. So we need to keep in mind that when I'm walking it, if something was to get in the way of my torch, I need to know before I go to weld, I can't make it all the way across at this angle. So I would have to do either something weird, maybe hold my torch upside down like this, and try to keep my tungsten aimed down into the metal. Okay? Or if I had a little bit of money, I could maybe get a flex head and bend that thing back, and now you can see I could kind of clear across that metal without hitting anything. So I like to hold it back on the back of the torch, and then I like to kind of swing it and roll it, and then swing it and roll it, and swing it and roll it. And notice how my tungsten never aims up. It should always aim down at that metal so that I'm keeping that base metal nice and hot and nice and wet, right? What I don't want to see is this. And I know that people do this. They're not wrong either. I just think it's more effective to aim the tungsten down all the time. My last tip is going to be for the wire hand. That was my advice on the torch hand. The wire hand, guys, it's going to either be, if we need to just lay the wire down, that's nothing. If we need to just tap it, that's easy too. But when we got to go feed it, that's where I got some advice for you, okay? If you have to feed that wire in for some reason, it's really common, and if you hold it really tight, you'll eventually kind of run out of wire. What I suggest, shout out to my buddy Alan for showing me this, is you can hold the wire a lot of ways. I like to do it in my palm like this, and it doesn't really take any effort. I just kind of squeeze these two fingers together like that. I'll hold the wire down here with my pinky, and then I just squeeze these fingers, let them go, squeeze these fingers, let them go, and you can see it's going to feed that wire into the pipe. Remember, it doesn't take very much. You're not trying to feed this much. You're trying to be real gentle when you TIG weld. So open your hand, squeeze your fingers, squeeze your fingers, squeeze your fingers. It's so great. It's so great. So here we go. I'm going to show you kind of what I was talking about, how to do it wrong. You can see now my tungsten's too high, my heat's too low, I'm not getting the base metal wet. I'm too far away from the base metal, and as you can see, if the base metal's not wet, even though it's enough heat to melt the wire, it's not bonding, it's not making a puddle. I can't have one be a solid, one be a liquid. So here I'm going to do it right. Here's my base metal getting a wet spot. There you can see the wet spot. I backed off for a second. When I lay the wire down into it, boom, it makes a puddle. They bond. So we have to keep that base metal wet, and as I'm going, I'm going to kind of lean my cup forward, which is a natural tendency of most people. If you lean it forward, the problem is that you're melting your wire before you can get it into that wet spot. And so you can see here, look down at the base metal. See how the base metal's not wet now. I've got myself too high, I've got myself too aimed forward, and it's melting that wire before I can get it into my puddle. So what do I need to do? Get straightened up, get that base metal wet, boom, now we can run a bead. Awesome. So again, the same thing still applies pretty much in all TIG. We gotta kind of keep, we don't have to aim straight down all the time, but we do have to keep that base metal wet. I'm gonna show you now kind of what it would look like, the same idea, just with a weave or with a walking the cup style. So get the base metal wet. Here I'm getting my wet spot started. And as you can see, with my tungsten aimed down into the metal, got my wet spot, and the bead's laying great. The wire goes right into the puddle. But the further I go, I'm gonna start leaning my cup back on purpose here. And you can see it doesn't want to wet the base metal up as well. It wants to burn the wire back away from me. It doesn't pull it into my puddle like I want. Here, I'm making the big loopy circles that I don't really like. You can see when I make that circle to go up over the wire, wire, it really pulls the heat off the base metal and it really melts that wire back away from me. So again, tightened up, heat down into the base metal, and it makes a great bead. When I get done, you'll be able to see the two parts, the beginning and the end there, where I had the cup down, I had the gas coverage well, I had my heat down into the base metal. It looks great. All the part in the middle where I was leaning it back too far or making those big loops, you can see it looks awful. Now that I've showed you a couple ways not to do it, I'd like to start back over and show you how to do this thing right. So I've got a couple of tests here all kind of done into one. They're similar, they're common tests, common things you would do with this high frequency. I'm going to first show you how to run some beads and how to overlap them. Then I'm going to show you a couple ways to do a lap joint, and then lastly I'll show you a couple ways to do a T-plate with this too, a fillet weld. First, I'm going to show you just how to make the beads and overlap them. So one more time, again, since I'm trying to weld down, I want to hold this thing straight down. I like to kind of back my hand up, make my little finger gun, and grab that valve right there. Then I can set my palm down, and I'm able to pivot on my palm and keep the torch aimed down. You'll have a really bad tendency of turning your hand up as you go forward. So by setting my palm down like this, I'm able to sit on it and pivot and keep that thing aimed straight down. This hand, like I said, I don't want to have it up here in my way as I'm welding. I don't want to be trying to get close and have to get out of the way of my wire to get it down there. So I'm going to keep my hand kind of set off to the side like this and keep the wire nice and low and real streamlined. For this high frequency, we're trying to do what's called a micro bead, right? Today we're running a micro bead. So the idea is small. You're not going to see me feed the wire in. You're going to see me just barely tap it and then move forward and tap it and move forward. The idea being less filler metal, smaller bead. Okay, so just like I said I was going to do, I've got my tungsten down close, I've got my heat into my base metal, and I'm just moving that puddle right along. You're more or less managing the puddle and then just adding some wire to it. Notice, guys, I'm not really lifting that wire up really high. I just kind of get it out of the arc, out of the heat, and then back down into it. Again, remember that these are micro beads that we're shooting for today. So don't get real excited about dabbing that wire in there a whole lot. The further you can space those dots out and the less filler metal you can give it, the smaller your beads are going to be. And so micro beads, that's kind of the goal of a micro bead, is tiny. So there's my bead. Looks pretty good, a little bit crooked, good enough for a government job, so I'm okay with that. On the next video, when I get back into it, I want you guys to notice that I'm going to start off of the bead on purpose to show you guys my wet spot, and then I'm going to bring it up onto my other bead. So there's my wet spot. I'm going to bring it up onto my bead. I watch the top edge of my puddle, and I keep it halfway up on that other bead, and I never let it come off there. If I'm welding and I notice that I missed my overlap for a second, I don't keep progressing forward, just go up and get on the overlap and then go about normal, like straight. I like to give you all a little disclaimer. I feel like that the second and third, or everything after the first bead, is going to take a little bit more heat. Technically, that metal's a little bit thicker now because we're welding halfway up on another bead. So here they are, they're done. Look at the front. See that wet spot up there, and see how I started it and then I drug it up onto my weld. So that was the laying the beads down and overlapping them. Notice I tried to get the edge of the puddle right on that halfway up on that other bead all the time. Before I go any further, I want you guys to see this little gap that kind of worked into that. Stainless is really bad about warping. So before I proceed, I'm going to get that gap out of there. Cosmetics wise, it's going to help me out. As far as getting things done wise, if I was in a factory, if I was in production, I wouldn't waste time with getting this gap out. I would just push more wire in there to fill that. Let's make it look pretty today though. So get my gap fixer, right? And then go to work on it. Hey, I like that. All right, so we got the gap out of there. We can weld now. So again, for the hand positioning on this, just the body positioning on this, I think I could give you guys a couple tips. I like to let you know that you have a natural tendency, I've said it before, but you kind of have a natural tendency if you weld across your body to turn your torch out like this. And that's bad. We got to keep the heat into the metal. So I'm going to take it and kind of line it up with me this direction. I like to take my torch hand and try to get it off the side. I understand that that doesn't always fit, but for the purpose of this test, is gonna go great. So I'm gonna get my torch hand off the side. That way I'm able to get any angle that I want, not be stuck at some kind of weird angle that I'm not trying to use. So get over here, and then I'm gonna kind of line the wire up just like this so that I can see what I'm doing. If I can, guys, some places the metal's too fancy and you can't touch this cup down. If I can though, I'll draw my tungsten out, I'll set my cup right on that plate or on that plate, and I'm just gonna slide it across that metal like that. So lined up with me just like this, and then I'm just gonna pull it to me just like that so that I can see what I'm doing. I've got it pulling to me like this because watch, I can pull this thing, you're fine, I can pull this thing all the way in, whoops, and not change the angle of it though. By doing a curl, I can keep it straight. If I was to go across my body, you'll just kind of go like this. You'll pull your arc out of the weld. That's bad. So set it up. I've set it up like this where I can pull it back to me. I'm right here where I can see what I'm doing. And then, like I said, I like to set my cup down and just drag it across that plate if I can. Not always can you touch your cup to the metal though. So I'm going to show you guys real quick 3 different methods to get this done. The first one, I'm just going to push so much wire in there that I get it filled up to the top plate, down to the bottom plate, and at a 45-degree angle. Flaw to that is that some of us aren't good at feeding the wire yet, so eventually you'll run out of wire and you have to stop and back your hand up down the wire. My second method, kind of what I would have to do when I started, is I like to run just a small bead down in there, not one big enough to touch the top plate, to go over the top plate, just a small filler bead down in there, and then when I get done with that, I'll come back and either lay the wire on top of it or dab it on top of that smaller bead and kind of put a cap, if you will. I'll really, really tightly just touch the top plate and then drag it down to the bottom plate. That way I get that 45 degrees again. This is still the small bead. You see just a little tiny bead. There it is. And now I'm going to come back with my bigger one. More or less, I'm just tapping that wire and just covering my bead up. I just go up enough to touch the top edge of that plate and then down enough to get it to touch the bottom plate. This is my favorite method if I had to choose. And then lastly, what I've done here is just got a lot bigger wire. If I wanted to make money, I would have to produce things faster. So instead of running that little tiny wire and feeding so much into it, I could just get a big enough wire and just tap it in there like every day. That's probably the best way if I don't have to run the tinier wire. If I can get bigger wire, then that's what I would do. Okay, so what just happened, guys, is I showed you 3 ways to do that lap joint. The definition of a lap joint is that however thick your metal is, that weld needs to go up to the top of that and then be 45 degrees. So it shouldn't suck in. It also shouldn't be smaller than that. Typically, that's 99% of the time, okay? So let me explain what we got here. First off, the first way is just to shove enough wire in there until it fills up to the top and then also down to the bottom, right? 45-degree angle right there. So you just push enough wire to fill it in. I used to have a hard time when I was new pushing the wire in, and I couldn't make it very far because I would kind of run out of wire eventually. So then I started doing it like this. This is my favorite way. I'll just run a small little fill bead down in there, and then I'll come back over it and I'll kind of feed the wire in and spread it around, and then feed it in, spread it around, feed it in, spread it around, right? So those are my 2 favorite ways with this smaller wire. If I had to choose, maybe I could just do it a whole lot faster though, and just grab a bigger wire and just go pow, 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 pow. So if it was production style and I have my choice, I would just grab a thicker wire and I would just lay it in like that. It's less feeding. So on the end here, I just got a bigger wire and I just kind of tapped it in like that. I didn't have to feed very much. Next, guys, I'm going to show you how to do this T-plate. More commonly, it's a fillet weld, or more accurately, it's a fillet weld. So again, there's a couple different styles for this, but again, I like to keep the idea that I don't want to turn my torch. So I'm going to set it up again to where I can pull it to me like this. I like to also set my cup down. Maybe that's not an option though. If I can touch my cup to this metal, this can be the easiest weld of all time. I would take my cup, I would go straight in, and I would set my tungsten to sit just right in the back of that joint right there. Then when I go to weld, I'll lean it forward just a little bit, and then I'm going to show you my signature twist. I just kind of twist the torch. And so see how it doesn't make it go very high up and down, but it still lets it progress forward? And so if I could touch my cup down to this metal, that's exactly how I would do it. If I can't, I'll have to kind of hold it off the metal and aim it towards the bottom more and real steadily pull it back to me like this. So here, first, when you very first start on a T-plate, sometimes you have to kind of adjust your angle, get both pieces of metal wet, and then you're able to just tap it down in there. This style, when I'm just wiggling that cup real tight like that, it's really important that I try to keep that wire fed, but also I can't let my cup lean forward very far because it will melt my wire outside of my puddle and it'll mess everything up. Try to keep your tungsten aimed in, try to keep that wire fed in nice and tight. The other option that I'll show you next is you're not always able to set your cup down, so I have to hover it. I like to aim my cup down towards the bottom, I like to aim my tungsten down towards the bottom a little bit more and let the heat kind of wash the weld up. What it does for me is it keeps me from having to stick my tungsten right in the crack of that joint and getting it stuck sometimes. So I like to back it up a little bit, draw my tungsten out, aim more down for the bottom plate and let the heat wash it up. So just like I said I was going to do the beginning one right here, I just kind of stuck my cup down in there. Here, I'll grab it for you so you can see it real quick. I just kind of set my cup down in there, made sure I kept my tungsten aimed into the metal, didn't let it come out. That's where you mess up, if you let it pull out like that. And then I literally just kind of twist the torch left and right a little bit so that I can scoot along there. The second one that I did, this one over here, that's more like how we'd have to do it if we weren't supposed to drag our cup, and I had to really carefully hold my cup right above that metal and keep the tungsten really close to the back of the joint and to the weld, and then just hover right over it and dab that wire in there, and then dab it in and dab it in. You're trying to get that wire right into your wet spot. So again, you don't want to turn forward so that you don't melt your wire before you're able to get it into that wet spot. You want to try to keep it tucked in all the way down there. Something I'd like to note, that at the end, if you saw the video, I had a little skip. Let's talk about that. That's called your range of motion right there. I should have, before I set this weld up, kind of felt it out and made sure that I could make it all the way. I got towards the end and my hand got my glove, got caught on a little burr, and then that caused me to skip. Feel that stuff out before you start welding. Before you run that bead, make sure you can run it. Make sure that that is all within your range of motion right there. So take that little note from my little mess up at the end right there, that I didn't feel my weld out before I did it. It can cause problems like that. Okay, everyone, so those are some real kind of practical scenarios that you would see with these with this high frequency. More or less, you'd see a lot of just pad and beads, really exact, really precise small welds, or lap joints, or fillet welds. It does get used in pipe. I've seen it maybe in the food grade industry where they're trying to have real tiny, real exact roots, not a whole lot of reinforcement on the back. I also have seen it a lot in the kind of aeronautical stuff, real exact welds, maybe on like turbine blades, or shoot, SpaceX, Elon Musk, watch this video and call me maybe, right? So there's a lot of things that this can get used for. It's really popular out there. Plus, just having the added benefit of knowing how to use this pedal. I use it all the time at my house if I wanted to weld exhaust. Maybe I'm welding that exhaust and all of a sudden I just blow a big hole in it because it's an old dumpy exhaust. I can just back off the pedal, fill it in, and keep going about my way. Okay, everybody, I'd like to leave today with a little bit of rehearsal over what we talked about. The main main point that I'm trying to make is to make TIG weld successful, we need to keep the heat down into the base metal. We need to focus that heat and get the base metal wet also. To make that happen, we're going to want to have really sharp tungsten. We're going to want to make sure we hold it really close to the base metal, and we're going to make sure that we have a good angle too. We're not letting it kind of naturally turn forward like this, okay? If I can, I'd like to leave you guys with a little bit of encouragement. I want to tell you that, guys, I've messed up a million beads. And so if you're having a hard time right now, if TIG is hard for you, that's okay. It was hard for all of us. Get in there and do it. I messed up during this video, okay? It's okay. Get in there, bust them beads out, and you guys can do this. If you liked what you saw today, there's a like, there's a share, there's a subscribe button down below. Also, if you have anything that you'd like to ask me, ask any of us. If you have anything you'd like to see, let us know in the comments. Best of luck, guys. Thanks for meeting with me today.